Hello ladies and gentlemen, we're going to go ahead and get started. We are going to do a warm-up before we get into the lesson, so go ahead and find your warm-up sheet. You should not need to get a new warm-up sheet in the back because this is only the third warm-up on the warm-up sheet that we've been using. After that, we're going to do lesson 3 on rational exponents and roots, so we're going to learn a little bit more about exponents. Then you can work on the assignment. Looking ahead, Mastery Quiz number 8, you will notice that it says date to be determined. Okay, I have not decided when I'm going to give that Mastery Quiz yet. It actually may be after the test. We shall see. I'll let you know more details when I am in class. We're going to definitely be reviewing for the Unit 6 test on Tuesday of next week. Again, that would be Tuesday, February 13th, 2018. And then the test will be Thursday, February 15th, 2018. All right, here we go. Warm up. So we're going to simplify each expression, and we learned about the exponent rules last time. And remember, there are 3 of them. You can either add the exponents, subtract the exponents, or multiply the exponents. And the biggest trick is to recognize when do you do the adding, the subtracting, or the multiplying. And it takes practice. Now, don't get a mind freeze and start applying these rules to things that are not exponents. Remember, these are for exponents. So, like this first problem, we have 15 over 5. Those are not exponents. Okay? So don't get a mind freeze here and start doing all kinds of weird things. That's 15 divided by 5. 15 divided by 5 is 3. Continuing. Now we have the exponent of 6, and it goes with the exponent of 4 because the bases are both the same. And remember, the rule here is to subtract. So that is x squared. 6 minus 4 is 2. Same thing with the y. The exponent of 7 goes with the exponent of 2 because the bases are the same. Subtract y to the 5th. Okay, the next one, you had a couple of these on your worksheet. Some of you asked me some questions about these. Okay, so first of all, we're going to do this one first. You will notice it's in parentheses, followed by a 2 for an exponent on the outside. And when we're done with that, then we will do this one. Again, it's grouped in parentheses with a 3 for an exponent on the outside. All right, so now remember, again, when you are doing this, is it an exponent or not? Like this 3 in front is a coefficient. It is not an exponent. So what this is, it's 3 squared. And 3 squared is 9. Okay, now here we've got an exponent of 4. And then 2 is also an exponent. So the rule here is to multiply. So that would be x to the 8th. Same thing with the 3. This 3 is an exponent. This 2 is an exponent. That is multiply. So that is y to the 6th. Okay, now I'm going to do the same thing over here. So this 5 again is a coefficient. It is not an exponent. So it's 5 to the 3rd power. And 5 to the 3rd power is, I believe, 125. 3. This 3 is an exponent. This is an exponent. Okay, that is the rule multiplication. So that would be x to the 9th. And then y to the 6th. That's 6 is an exponent to the and 3 is an exponent. So that's y to the 18th. That's where, again, we are multiplying them. Now, we're not done because now we're going to take these 2 things and put them together. Okay, now it's a multiplying. All of this was being multiplying. I don't see any adding or subtracting anywhere in that problem, so it's multiplication. Now again, 9 is a coefficient. 125 is a coefficient. Do not apply the rule of exponents to those. So it's 9 times 125. And you get 1,125. Now, the exponent of 8 goes with the exponent of 9. Now, again, look at it. This is the first rule we talked about. This is where we will add the exponents together. So that will be x to the 17th. Again, you got to recognize there's three formats that you need to look for. Okay, and then the 6 goes with the 18. Again, we're going to add them. So that would be y to the 24th power. So that is our final answer. All right, that is your warm-up. The next thing we're going to do is the lesson. And you should be getting, I believe it is a purple worksheet handed to you. If you don't already have it, make sure that you get it before we continue the video. All right, we're going to begin. All right, so there's quite a few things we need to talk about. First of all, we need to know our perfect squares. Okay, I have a few of them listed. So you should have a few of these memorized, hopefully all of them. So 1 squared we know is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. And again, at any time, if I'm going too fast, you can pause the video, rewind it, and so on. Okay, and then you'll notice I just did ... and then 12 squared is 144. So you should have memorized 1 through 12 for sure, hopefully maybe even a little bit further. Now, the middle column is dealing with square roots. Now remember, a square root is undoing a square. Now on your calculator, if you need the square root button, the square root button is on the left side. It is a second function, and then the x squared button. Again, it's on the left side of your calculator. Second, and then the square root button. Okay? All right, but we don't need that yet. All right, so the square root, so if I rewrite this, that would be the square root of 1. And the square root of 1 we should know is 1. The square root of 4, that will give us 2. The square root of 9, that will give us 3. The square root of 16 will give us 4, and so on. Now, the square root is nice. However, we also have what we call rational exponents. Now, we're going to need to use these when we solve equations. We don't want to use the square root button, so we have to learn another way on how to find square roots, but without using the square root button, and that's called a rational exponent. All right, so here we go. So the square root can be written as a fraction. So, like the number 1, the fraction, the exponent would be to the 1/2 power. Okay? 4 to the 1/2 power is 2. 9 to the 1/2 power is 3. And so on. 16 to the 1/2 power. Again, the 1/2 power is a replacement for the square root. 25 to the 1/2 power is 5. 144 to the 1/2 power is 12. Something that is very, very important, though, when we're using the calculator. Okay, so we need to write this down. When using the calculator, always use parentheses on fractions. Always. Okay, so let me show you with the calculator. Okay, we already know the square root. Like, we know the square root of 25. Okay, now, those of you with older calculators, you're going to have a parenthesis. You should close it. Okay, the square root of 25, we know is 5. Now, again, our goal here is to get away from the square root, because we're going to learn about some other roots here in a little bit. So, what I want you to use is 25. Now, we're going to hit the caret key for an exponent. And we must use parentheses. And the replacement for the square root is the exponent of 1/2. So you can see 25 to the half power is 5. Okay, I'll do it one more time. So 144 to the, again, please use parentheses around your fraction. 144 to the half power is 12. So we are going to start using what we call rational exponents. Rational exponents. All right, let's continue. Now let's do some perfect cubes. So 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. 4 cubed, 64. 5 cubed, 125. 12 cubed, 1,728. Okay? Now, how do you undo a cube? Okay? That is called the cubic root. Now, what does the cubic root look like? Okay, we make the symbol for the square root, but we put a little 3 right there. So the cubic root of 1 is 1. The cubic root of 8 is 2. The cubic root of 27 is 3. The cubic root of 64 is 4, and so on. Okay, I'll just fill the rest in here. Now, I will show you where the cubic root button is, but it is a button that we really do not need to use because we're going to have rational exponents here in a little bit. But if you do want to see the cubic root button, it's under math. So you have to hit your math button, and you'll notice it's the 1, 2, 3, 4th one down. You'll notice it puts a 3 in that spot. So, like the cubic root of 8 is 2. So that's where your cubic root button is. Again, it's under math. Sorry about that. There's a little pause there. Again, it's under math, and it's number 4. All right, but again, I really don't want you to use that. So let's go back to the worksheet. So what is the rational exponent for this? So the rational exponent for the cubic root is 1/3. So 1 to the 1/3 power is 1. 8 to the 1/3 power is 2, and so on. 27 to the 1/3 power, 64 to the 1/3 power, is 4. 125 to the 1/3 power is 5. 1,728 to the 1/3 power is 12. Now, again, you must use parentheses when using your calculator. All right, so just to demonstrate, we've got 64, caret key to the 1/3 power, which is 4. So again, instead of using the cubic root button, again, I don't want you using the cubic root, and there's a reason for this that we're going to see in a little bit. I don't want you using that. I'd rather have you use to the 1/3 power. All right, continuing. Additional notes. Now, I want you to understand how this works. What is this rational exponent telling us? Okay, for example, let's say we have 8 to the 1/3 power. Okay, the denominator is telling us how many factors there are. So the denominator is 3. So what number do we multiply to itself 3 times that gives us 8? Well, it's 2 times 2 times 2. So again, this 3, the denominator, is telling us there are 3 factors that give us 8. And it's 2 times 2 times 2. It's the same one. And the top number, the numerator, tells us how many of them we want. We only want one of the 3. So that's why the answer is 2. Okay. Let me change now to 8 to the 2/3 power. Again, 8 is, we get 8 by 2 times 2 times 2. That comes from the denominator of 3. Okay, let me color code this. So this denominator tells us there are 3 2's. 2 times 2 times 2 gives us 8. Now, the numerator tells us how many we want. We want 2 of them. So 2 times 2, the answer is 4. Let me show that with the calculator. Let me prove that to you. Okay, so we have now 8 raised to the 2/3 power. And we're going to get 4. All right, let me demonstrate that again, because this is a very important thing to remember and to understand how this works. All right, let's switch numbers this time. Let's go with 64 to the 1/3 power. Now, 64, what number do we use 3 times that gives us 64? Well, that would be 4. 4 times 4 times 4. And the top number, the numerator, tells us we want one of them. So that's our answer. Our answer is 4. If I do 64 to the 2/3 power, again, I have 3 4's. The numerator, 2, tells us I'm going to use 2 of them. So that would be 4 times 4, which is 16. So 64 to the 2/3 power is 16. Okay, let me demonstrate that. 64 to the 2/3 power is 16. So that's what the rational exponent is doing. Okay, let me demonstrate one more here. One more. All right. Hopefully this won't blow your minds away. 8 to the 5/3 power. Whoa, the numerator is bigger than the denominator. So again, the denominator, 3, tells us there's 3 numbers that multiply to give us 8. That would be 2 times 2 times 2. But the numerator says we need 5 of them. So 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5 of them. And if we multiply all of those together, that should be 32. Well, let's see if the calculator does that. So I'm going to take 8 raised to the, again, use parentheses around your fraction, 5/3 power. And voila, it is. It's 32. All right, let's keep going here. Let's go to the power of 4 real quick on the next page. So 1 to the 4th power we know is 1. 2 to the 4th power, 16. 3 to the 4th power, 81. 4 to the 4th power, 256. 5 to the 4th power, 625. 12 to the 4th power, 20,736. Now, the 4th root would look like this, and I'm not going to show you, I'm only going to show you the rational exponents with the calculator with this, but if we wrote this out, it would look like this. It would be the 4th root of 1, which is 1. It would be the 4th root of 16, which is 2. The 4th root of 81, and so on. The 4th root of 256. The 4th root of 625. The 4th root of 20,736. Okay. But again, we do not want to use the 4th root at all. We want to use the rational exponent. Okay, you should know this by now. So the rational exponent is going to be 1/4. Okay, I'm just going to write the rest of these out. Okay. Just real quick, a little additional note here. I'm just going to do what I did on the front, like 16 to the 3/4 power. Again, the 4 in the denominator tells us what number do we multiply to itself 4 times. Well, 16 is 2 times 2 times 2 times 2. And we want 3 of them. So the answer is 8. And if I type that in, we get 8. Okay, let's go to the bottom of page 2. Things to remember. First one, you can't work with negatives when you have even roots. They are called imaginary numbers. All right, so like the square root of -2. Okay, I have not taught you the imaginary stuff at all. Okay, just know that that is what we call an imaginary number. Okay. If I did the 4th root of a negative number, again, that's going to be an imaginary number. Okay, I'm not going to go any further with it than that. So that's what that first statement says. You can't work with negatives when you have even roots. Okay, the next statement. You will have 2 answers when solving equations with even roots. Okay, you already know that. Okay, for example, if I have x squared equals 16, and we take the square root of both sides, x equals positive or negative 4. So 2 answers. That's what that statement is saying. Okay, now an even root, that means if the exponent is, or the root is a 4 or a 6 or an 8 or a 10, you still are going to get 2 answers. All right, the next statement. You can work with negatives when you have odd roots. So, for example, if I have the cubic root of negative 8. Now remember, that's the same as negative 8 to the 1/3 power. That will work. Negative numbers will work with roots that are odd. And that answer is -2. Go ahead and try it on the calculator if you want. Like if I did the 5th root of -243. Okay, well that's the same as -243 to the 1/5 power. That would give you -3. So that's what that third statement is saying. And the last statement, when you will have one answer when solving equations with odd roots. So 4 very important things to remember, because what we're going to do next is we're going to actually go in, well not quite yet, but we're going to go and solve some equations with rational exponents. Before we continue though, there's one more thing I need to talk about. Okay, some of you ran across this, well all of you ran across this when you did your worksheet. You ran into some negative exponents. And some of you were questioning that, can I have a negative exponent? Well, in math, technically, negative exponents are not allowed. Okay, well, what in the world are we going to do if we run into a negative exponent? Okay, there's a phrase that goes with it, and you may have heard Mr. Hoenigs talk about it. It's called cross the line, change the sign. For example, 2 to the -3rd power. It's going to be a fraction. You're going to cross the line and change the sign. So the negative exponent is now a positive exponent. Now, what goes on top? Well, you can't have a 0 there. Okay, there is a number there. Remember, when you don't see a number, it's a 1. Now, if you figure out what 2 to the 3rd power is, which you should know because it's on page 1, 2 to the 3rd power is 8. So 2 to the -3 power is actually 1/8. And just to prove that to you, let me demonstrate with the calculator. So if I typed in 2 raised to the -3 power, and then I hit my fraction button, okay, there it is, 1/8. 2 to the -3 power is 1/8. All right, so let me do another one. So if I have 3 to the -4 power, again, cross the line, change the sign. So that would be 1/3 to the 4th power. And 3 to the 4th power is 81, so my answer is 1/81. Okay, so cross the line, change the sign. This also works with variables. For example, if I had x to the -5 power. Okay, some of you saw that on the last worksheet. That's where you're going. There's a negative exponent. What do I do? And I said, just leave it alone. I'll teach it to you later. Okay, this is where it is. I'm teaching it to you now. We're going to cross the line, change the sign. So again, we're just going to put a 1 on top. So that would be 1/x to the 5th. So that would be in the denominator. Okay. For example, let's say we had one like this, where you had x to the 4th power and y to the -6 power. Well, the x to the 4th power is fine. There's nothing wrong with it. It stays where it is. But the y to the -6 power needs to cross the line and change the sign. So it becomes x to the 4th over x to the 6th. It can also work in reverse. Let me show you that real quick. Didn't leave myself much room here, but it works in reverse. Let's say that I had I ended up with 3 over x to the negative 4 power. Okay, again, we're not allowed to have negative exponents. So we're going to cross the line and change the sign. So that means I'm going to move it up, and it becomes positive. So the answer here would be 3x to the positive 4. Cross the line, change the sign. All right, we're going to solve some equations, and I'm just going to step through them fairly quickly. Obviously, I'm not in class to pause and to walk around and check your answers. So again, if you need to rewind at any time to see what's going on, please do so. All right, here we go. There's actually quite a few of these that we need to go through because there's something a little bit different about each one. The first one, we have 6x to the third power equals 384. Remember, our goal is to get x by itself. So step 1, we're going to divide by 6. So now we have x cubed equals 64. All right, here we go. Now, this is the whole reason I taught you the rational exponent stuff. We've got to get rid of the 3. We're not going to cubic root it, ladies and gentlemen. We are going to multiply the exponent with 1/3. When we do that, the exponents here cancel each other out, and we're left with the letter x. And now, take your calculator and type in 64 to the 1/3 power. Okay, I'll do it with this one, but after this, you can do it on your own. So we've got 64. Well, it looks like my calculator froze, so I'm not going to do it. So type it in, 64 to the 1/3 power. And you're going to end up with, now, keeping in mind, oh, it's an odd exponent. What did I just learn about an odd exponent? Oh, an odd exponent only has one answer. One answer. So this answer would be 4. X to the 1/3 power is 4. Okay, next one. So this one says 3 times x to the 4th power equals 3,888. Well, first thing I'm going to do is I'm going to divide by 3. And I have x to the 4th equals, all right, 3,888 divided by 3 is 1,296. Now, I need to get rid of the exponent of 4. So I'm going to multiply the exponent by 1/4. Remember, what you do to one side of an equation, you do to the other. So now this is all going to cancel, but I need to do to the 1/4 power over here. So again, take your calculator, type in 1,296 to the 1/4 power, and it's an even exponent, so that means we're going to have two answers. There's going to be a positive and a negative, or a plus minus, and 1,296 to the 1/4 power, did you get it? It's 6. Please practice it. Pause the video and see if you can get the calculator to get that to show up. All right, next one. You will notice that the -8 is inside the parentheses. There is a 5 for an exponent. You cannot subtract 8. Right now, that -8 or add 8, that 8 is locked inside the parentheses, and the exponent is keeping it locked inside. So the first thing we have to do on this problem is get rid of the exponent. So, just like we did with the 2 up above, we're going to get rid of the 5 by using 1/5. 5 times 1/5 is 1, so that's gone. So what we're left with is x minus 8 equals. Now again, 5 is an odd exponent, so we do not need to worry about having two answers. This one only has one answer. Okay, and 243 to the 1/5 power is 3. Now add 8, and so our answer is 11. That's it. Next one. Again, you will notice, ladies and gentlemen, that the 7 is locked inside the parentheses because there's a 3 for an exponent keeping it locked in. So we need to get rid of the 3 first. So to get rid of the 3, we're going to use 1/3. And again, what you do to one side, you do to the other. So the 3 and the 1/3 cancel each other out. We are left with x plus 7 equals 343 to the 1/3 power is 7. Okay, subtract 7 from both sides. And we find out, ladies and gentlemen, that the answer is 0. There is only one answer to this problem because the exponent is odd. Continuing. So again, each example has something a little bit different, so make sure you follow along carefully as we go through these. Okay, the next one. We have 2x to the 4th minus 9 equals 503. Okay, there are no parentheses, so we need to first add 9. So 2x to the 4th plus or equals 512. Divide by 2. So now we have x to the 4th power equals 256. Now, we have an even exponent. That tells me there are 2 answers, so we're going to have a plus and a minus. All right, we're going to get rid of the 4, so we're going to use 1/4. Again, the 4 and the 1/4 cancel each other out. And 256 to the 1/4 power is 4. So our answer, there are 2 of them because it's an even exponent. Our answer is plus or minus 4, positive or negative 4. Okay, moving on. Next one, subtract 4. Divide by 5. Again, it is an even exponent, so that means we're going to have a positive and negative answer. Get rid of the 6th. We're going to use 1/6. 6 and 1/6 cancel. And 729 to the 1/6 power, and again, make sure you're using parentheses, we will get 3. So the answer is positive or negative 3. Okay, moving on. Now this one we have a couple more steps involved. Step number 1. We are going to take away 2. So we have 3 times x minus 4 squared equals 75. Now, the next thing that we do, that far too often students are making a mistake here. Do not distribute. Do not distribute. The exponent of 2 is preventing you from that 3 from getting into or inside the parentheses. So we do not distribute. We have to get rid of the 3 by dividing both sides. All right, so now we have x minus 4 squared equals 25. Now, this one, there's a little bit more here that we're going to have to do. Okay, the next thing is we are going to have to take the square root, or not the square root, but to get rid of the 2, we're going to use the half power. Again, the 2 and the half power cancel. So what we're left with is x minus 4 equals. Now remember, it's an even exponent, so it's going to be a positive or negative 5. Whoa, okay. Again, pause and think about what I just did, if you need to. There are going to be two answers. So what I'm going to do is I'm going to add 4 now, because I got to get x by itself. Okay, so one of my answers is going to be the positive 5 plus the 4, which is 9. The other answer is going to be 5, or negative 5, plus 4, which is negative 1. So my two answers are 9 and negative 1. Okay, you may need to rewatch that one again if you didn't get it. Okay, next one. Now, I'm going to look. Oh, I noticed right away I've got an odd exponent. I don't have to worry about two answers. So I'm just going to solve it and get an answer. Okay, again, I got to start by adding 8. Then I'm going to divide by 7. Now I got to get rid of the 5, so I'm going to use the 1/5 power. 5 and 1/5 cancel. So I have x plus 3 equals, and 1024 to the 1/5 power is 4. Again, odd exponent, I only need the 4. I do not need a plus and minus, only if it was an even, but it was an odd. Lots of things to remember here. Take away 3, and voila, the answer to this one is 1. X equals 1. All right, continuing. Now these next two look a little weird. We've got 9x equal 9 to the x power equals 27. So what we're going to do to help us with this, all right, so I'm going to rewrite this so I have a little bit more room. So 9 to the x power equals 27. I'm going to rewrite this so that I have the same base. You know how important the same base is when you're dealing with exponents. So I'm going to rewrite 9. 9 can be written 3 squared. Again, 9 can be written 3 squared. And then there's an x already there in the exponent, so I'm going to put that behind the 2. So 3 to the 2x equals 27 can be rewritten with a base of 3. Notice, same base. And that can be rewritten as 3 to the 3rd power. So I rewrote the two numbers so I have the same base. Now, since they are the same base, all we have to do is take the two exponents and set them equal to each other. We can drop the bases. Now I divide by 2, and I find out my answer is 3 over 2. Whoa. Okay, I'm going to check the answer. Okay. If I take the calculator, and again, my calculator's frozen, so I can't use it. So 9, if I take 9 to the 3 over 2 power, type that into my calculator, I'm going to get 27. Pretty cool, huh? Okay, there's another one there. 32 to the x equals 128. So again, I'm just going to rewrite this down here. 32 to the x equals 128. So what I want to do is I want to figure out the same base. What is the same base for 32 and 128? Well, Well, the only thing that I can think of, 4 might work. Let's see. Can I make 32 out of 4 though? 32, 4, no. 4 times 4 is 16. 16 times 4 is 64. No. So 4 is not going to work. So it's going to be a 2. So 32 can be rewritten as 2 to what power? 2 to what power gives us 32? Okay, 2 to the 5th power. 2 to the 5th power is 32. Now again, there's an x there already, so I'm going to write 2 to the 5x power equals 128. Whoa. Okay, 2 to what power is 128? Well, that would be 7. So again, I rewrote 32 into 2 to the 5th. I wrote 128 back into 2 to the 7th. And then I put the x back on the exponent right there. So now that the bases are the same, I can set the two exponents equal to each other, divide by 5, and I find out that x equals 7/5. So that is the missing exponent. Take your calculator, type it in, 32 to the 7/5 power, and you should get the answer. All right, we need to wrap this up. So let us go to the next part. We are going to convert. This will go really fast, and then the rest of the time is for you to work. Convert each radical expression to exponent form. All right, so it's just a matter of putting the numbers in the right place. So our base is x. We're going to make a fraction, a rational exponent, so we're going to make a fraction here. And the numerator is going to be the 3. The denominator is going to be the 4. Okay, look at where the numbers are and where they go. Next one. The base is x. I'm going to make a fraction. I only see the number 5. The 5 is going to go in the denominator. Well, I do need a numerator. Since there's nothing there, I need to put a 1. So x to the 1/5 power. Okay, the next one, again, the base is x. I'm going to make a fraction. I see the 7. The 7 is the denominator, and then the 3 is the numerator. Again, look at where the numbers are located in the radical, and then look at where the number ended up in the rational exponent. And finally, we're going to go the other direction. So we're going to make the radical symbol. We're going to put the base inside. Now, where does the 5 go? The 5 goes here, and the 4 can go right there. Next one. Make the radical. Put the x inside. The 7 goes right here. And the 1, we don't need to put the 1 anywhere. Okay, if you wanted to put the 1, you could put it by the x, but it's not necessary. And then the last one, again, we're going to make a radical. We're going to put the x inside. The 3 goes here. And again, the 4 can go here. It's just a matter of memorizing where each part fits. All right. I shall see you next class. Bye.